Hello everyone, we are Group 4 from E Division and topic of our presentation is Working of Interrupt Driven IO. Myself Aditya Dhakne and our group members are Suvidha Dhakne, Atharva Dhakate, Mayuresh Dhale and Vedant Dhamne. The topics we have covered in the presentation are Introduction, Working, Advantages, Applications, Objectives, Conclusion and the diagram of the Interrupt Driven IO. I will be starting with the introduction of interrupt driven IO. Basically interrupt driven IO is a method of input or output processing in which the processor is interrupted by an external device such as a network card or hard drive when data is ready to be transferred. Interrupt driven IO differs from other IO methods such as programmed IO and direct memory access. Discussing the importance of interrupt driven IO in modern computing systems, particularly in high performance applications where efficient IO processing is essential.
Working of interrupt driven IO. When an interrupt is triggered by an external device, the processor temporarily stops its current task and jumps to an interrupt service routine that handles the interrupt. The ISR reads or writes data from or to the device and then return control to the main program. The main program can continue executing without waiting for the IO operation to complete. The processor can handle multiple interrupts simultaneously, allowing for efficient processing for multiple IO operations.
Let me see the advantages of interrupt. The interrupt reduce the CPU overhead, that is the interrupt drive input output allow the processor to perform other tasks while waiting for input output operation to complete rather than wasting cycle on the pulling for a data. So what is pulling? Keep watch all the time for interrupts. So next advantage is improve input output performance. Interrupt drive input output can handle multiple input output requests simultaneously, allow for faster overall processing. It allows faster processing. Then scalability. Interrupt drive input output can handle a large number of input output requests, making it suitable for high performance and computing application.
So let's talk about the applications of interrupt driven IO. Interrupt driven IO is commonly used in a networking applications to handle the high volume of incoming and outgoing data. Basically, interrupt driven IO is also used in storage systems such as hard drives and solid state drives to read and write the data efficiently. Interrupt driven IO can be used to interface with a wide range of input or output devices such as printers, scanners and keyboards, etc. Further, let's talk about the objectives of interrupt driven IO. The basic objectives of interrupt driven IO are to send a signal to a peripheral or a terminal that needs to make or receive a data transfer, then causing a program interrupt to be set at a time appropriate to the priority level of the IO interrupt.
Previously, we have seen that all the concepts of interrupt driven IO were explained by my group member. Now, we will come to the conclusion of the topic. Interrupt driven IO is an important technology that plays a critical role in a modern computing system. By understanding its working, advantages and challenges, we can design and implement more efficient and effective IO solutions that drive innovation and progress in the field of computer science. Now, we will see the flow chart about interrupt driven IO which explains working of it. Before that, there are some basic operations of interrupt. CPU issue read command. IO module gets data from peripheral while CPU does other work. IO module interrupts CPU. CPU requests data. IO module transfer data. Now we will see the detailed processing of interrupt driven IO. A device driver initiates an IO request on behalf of a process. The device driver signals the IO controller for the proper device which initiates the requested IO. The device signals the I/O controller that is ready to retrieve input, the output is complete, or that an error has been generated. The CPU receives the interrupt signal on the interrupt request line and transfer control over the interrupt handler routine. Then the interrupt handler determines the cause of the interrupt, performs the necessary processing, and executes a return from interrupt instruction. So the CPU returns the execution state prior to the interrupt being signaled, and then finally the CPU continues processing until the cycle begins again. This is how the interrupt driven I/O works. Thank you.